All right. We're on to lesson 3.5 here, projectile problems 1. We're going to do 1 and 2. Projectile problems 1 and projectile problems 2. Go ahead and write these equations down. These are all the equations we have for a projectile. The distance in the x direction, remember, was just constant velocity. So you just take your VXO times t. Your distance, or your actually displacement, not distance, these are displacement in the y direction, was this longer equation because it's accelerating. Your velocity in the y direction is this because you're accelerating. And remember, your Vx, your velocity in the x direction, is just constant. So there's no equation for that because it's just constant. It's always the same, your Vx. Okay, so there's basically two types of problems you'll see on this lesson or this assignment, but they're both going to have to do with the horizontal projectile. So this projectile is launched horizontally, it will say, off of some height. They'll give you the initial speed. Okay, so your VXO is the speed here. Your VYO, your initial y velocity, there's none, right? There's no arrow up and down. So on these problems, your VYO is 0 because of the horizontal. They'll give you a height here, which is like your distance in the y direction. Okay, and then there's be a bunch of questions you have to answer. And if you just do these questions in order, that would be the easiest thing. It's kind of a progression. Okay, so in this case, I have 4 questions. Okay, so time to the ground. Let's start with that. The thing is, we know is this is our dy. It's really negative. If we count this as 0 for 0 height or 0 displacement, then dy when it hits the ground is going to be negative 30. Okay, so to get to the ground, let's use this equation. Negative 30 is the distance in the y. This is 0 because we're saying we're just counting this as 0 height. Our VYO is also 0. Our A, or acceleration for the vertical, remember, is negative 9.8. And then t squared. Okay, so if you solve that out for t, okay, divide each side by negative 4.9 and square root, I got down to t is 2.47 seconds. Okay, that answers that first question. How long does it take to hit the ground? Okay, how far does it go horizontally? Now we're talking dx, right? How far does it go horizontally? dx, that's your VXO times your t up here. So VXO is just 10 time, okay, for it to get to the ground, 2.47 seconds. Okay, so 24.7 meters is your dx. That would go here when it hits the ground. Okay, next question there. What's the velocity when it hits the ground? So now we're looking at our Vx and our Vy situation. So this is all involving distance. Now let's look at our velocities. Vx, when it hits the ground, is still going to be 10. Remember, that's just constant the whole time. So your Vx is 10. This is at the ground. Okay, your Vy, we're going to have to use that equation. Vyo plus AT. Vyo, it was actually 0, right? Acceleration is negative 9.8. Your t to get to the ground, 2.47 seconds. So really, we're just talking 9.8 times 2.47. 24.2 meters. Zoom in there, it's kind of blurry. Per second, meters per second. Okay, so we got this scenario when it hits the ground. that's the components. Now, if I want the overall velocity when it hits the ground, I got to look at the vectors and say, okay, it's going 10 meters per second this way. It's going 24.2 meters per second this way. How fast is it actually going on an angle, right? Remember we made this rectangle and drew this vector on an angle like this. That's how it's actually traveling. So the actual velocity here, you would go through Pythagorean theorem, which, you know, you can do that pretty quickly, right? 10 squared plus 24.2 squared, and then square root that answer. I'm getting, oh boy, screwed that up. 10 squared plus 24.2 squared. Oops. And then I'm doing to the 0.5, which is square root 26.2. Okay, that's how fast it's going when it hits the ground. And then the angle is going to be the angle from horizontal. So I'm going to look for this angle here. I'm going to call it theta. Okay, how far is it down from horizontal when it hits the ground here? 24.2 is here, right? So we're talking tan of theta is 24.2 over 10, opposite over adjacent. So theta would wind up equaling the tan inverse of 24.2, you know, meters per second over 10 meters per second. So really tan inverse of 2.42, right? Looking like 67.5 degrees, okay? So that answers those last two questions there on what's the velocity when it hits the ground. That's 26.2. And what's the angle? It'll be 67.5 degrees from horizontal. Okay, let me give you a little insight on the other type of problem you'll see. We aren't going to work through the whole thing, but you'll see a problem like this. It'll say, you know, it'll give you the height. It'll tell you how far it landed here. And then it'll ask you a bunch of questions, you know, same kind of questions. How long is it in the air? What was this initial velocity up here? What was the velocities at impact? And what was the angle at impact? We aren't going to go through this whole thing to save you a little time, but I want to get you started on it. Okay, so time in the air. The thing we know again is that our dy is this negative 30. Okay, so you would go through those same steps as we did over here. Your dy is negative 30, and you could find the time. The time will be the same. It'll be 2.47 seconds for this scenario because it was still 30. The initial velocity, that's what I want to show you. So we're talking our Vx, right? Our Vxo, which is the same as our Vx. So go back to, and we know this is our dx. Okay, so let's use our dx equation to work backwards. So remember, dx is Vxo times t. The dx is the 20. Vxo is the thing we don't know. How fast was it going up here? But I do know it took 2.47 seconds to get to here. All right, so really we're just talking 20 divided by 2.47 is 8.1 basically meters per second. Okay, that's how fast it was going when we launched up here. And then one last thing I'll just explain to you is, you know, what about at impact? Well, now we're talking, you know, when it hits that ground there, you know, how do I figure out all these other things? Well, sorry, this is 8.1. So if I was trying to find a velocity when it hit the ground, well, I know this is still going to be 8.1, but my Vy here, you're going to have to go through that equation. Remember, that was my Vyo plus 8t if you look at the equation. All right, so Vyo is 0. I got to do negative 9.8, and it was falling for 2.47 seconds. So really, it's the same as it was on the front, on the other side there. It's really still 24.2 in this case. okay, that would go here. That's my Vy. This is my Vx. Okay, and then from there you could figure out this again. It'll be different because it'll be different than it was on the front because this is different. And you could figure out the angle, which will also be different because this is different. Okay, but similar to the one on the front. Okay, those are the two types of problems you'll see today on horizontal projectiles.